All right, on here to page 2, we're going to continue our discussion about periodic trends and properties of the periodic table. So here we have a list of different families on the periodic table, and we're going to talk about their location and their special qualities or properties that all of them share. Again, columns on the periodic table are called families, and all of them have similar chemical and physical properties. So we'll start here at alkali metals. That is column number 1. Our alkaline earth metals is column number 2. Transition metals is going to be groups 3 through 12. That is the large chunk right here in the middle of our periodic table. Our halogens is column 17. It begins with fluorine. Noble gases is the very last column all the way to the right, and that begins with helium. And then our inner transition metals, those are the 2 rows that you may be wondering what are they at the bottom of the periodic table. These are their inner transition metals. Again, they are removed and put on the bottom just to make the periodic table fit nicely on one page. Now we're going to talk about the special qualities that these families all share. The first one being the alkali metals. Now column number 1, what's special about these is they all have one valence electron, and they want to get rid of that electron, so they're willing to do it, and it's relatively easy for them to be able to get rid of that electron. So these are the most reactive metals of anything on the periodic table. So we're going to write there's letter K, sorry. Number 2, the alkaline earth metals, that is column number 2. They are not as soft and chemically reactive as the alkali metals. So they're similar, but just not as reactive and not quite as soft. Number 3, here we have the transition metals. These ones form brightly colored compounds. Halogens, again, halogens is the family of the column that begins with fluorine. And remember, we talked about her. She is the most electronegative element, meaning she will take these columns right here, these columns of elements, take electrons relatively easily. They have a high electronegativity value. They are the most active or most reactive nonmetals. Moving down here to the noble gases, because they have a full octet rule of electrons. Again, the noble gases is column 18. We start with helium all the way down here to radon. They are the most unreactive element on the periodic table because they already have their full octet, 8 valence electrons. So our last one is the inner transition metals. These are mostly synthetic and radioactive, meaning they are man-made elements. So element 92, if you see right here, uranium is the actual biggest naturally occurring element in the universe. Everything after that is man-made and synthetic in a lab. Hi guys, the last section of our review is talking about a certain set of elements and then coming up with the various electron configurations that we've been focusing on, what family they are in, and the number of valence electrons. Because this part of the review is so small, I went ahead and made a card for each one of them. So I'm going to display the first one here, which is lithium. So lithium is element number 3 on the periodic table. And for all these elements, we're going to assume that it's neutral, meaning it has the same number of electrons as it does protons. So we have 3 electrons in the element for lithium. And so right here we have an electron configuration of 1s2, 2s1. And we're going to go ahead and underline the number of valence electrons, which is going to be 1. Now to do the orbital diagram, we always start for any element with 1s, and we put 2 electrons in any room before we move on to the next room. So we have 2 electrons here, and there makes our 3rd electron. So we add them all up, we have 1, 2, 3 electrons total for lithium. And the noble gas configuration, if you remember, so lithium is here in row number 2, so our period number 2. And to do the noble gas, we're going to go up the previous row all the way over to the noble gas before it, and we're going to write that noble gas in brackets. And then after we write that noble gas down, we're going to continue counting our our electrons. And so here we have the second row, so it's going to be the 2, and this is the s orbital room, and there's only 1 electron in the s orbital room, which is where we get 2s1. So moving on here just a little bit faster, here we have silicon. So silicon is element number 14. It is in row number 3 on our periodic table, right here next to aluminum. It has 14 electrons. So starting off at element number 1, we have our electron configuration here as 1s2, 2s2, 2p6, 3s2, 2p2. And I went ahead and underlined the number of valence electrons. which will give us a total of 4. Now to do the electron orbital diagram, we always start off at 1s, and we put 2 electrons in the first room of our electron hotel before we move on to the second floor. And so there's going to be 2 electrons here, so we've totaled up to 4. It means we have 10 more to go. Now here we are, we're going to move on to the 2p room. We're going to make sure every bed is full in our electron hotel before we double people up in each room. Right there. And so now we're moving on to the 3s room. So we have 2 electrons in the 3s room, and now we have 2 people in, I'm sorry, that was a typo right there. That should be 3p, I apologize. That is going to be 1, 2 in our 3p room. We don't want to put 2 electrons here in the first shell. We want to spread them out as far as possible before we double those electrons up. So this is silicon. Moving down to our noble gas configuration, we write down neon, because silicon is in row number 3. You go up to the row before, all the way over to the noble gas and write it down, and then continue to count electrons in the row following, which is what we did here. So we have 3s2. Again, sorry about that typo right there. That should be 3p2. Next element is going to be magnesium, which is element number 12 on our periodic table. It is in row 3 right here. So again, we always start off in our 1s shell. So our electron configuration reads 1s2, 2s2, 2p6, 3s2, and I underline our number of valence electrons, which is going to be 2 valence electrons. Doing our orbital diagram similar the way we did before. The first 2 electrons are going to go in the 1s shell. The next 2 electrons are going to go in the 2s shell. In the 2p shell, again, watch carefully, we fill every single room with 1 valence electron, and then we come back and we fill in the second electrons in that shell. And the last one, we have 2 electrons in our 3s shell. So you can easily see here the outermost shell has just 2 valence electrons in it. Our noble gas configuration is neon 3s2. Our next one here is zinc. So this is element number 30 on the periodic table. It is actually the last element of the transition metals for row number 4. So it's right here, element number 30. So we have to do something slightly different here. We're going to add the d orbital in. So our electron configuration, is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then we add in our 3d10. Now the d orbitals do not count towards valence electrons, so we move back 1 shell, and so this means that zinc has 2 valence electrons. Coming down here to the orbital diagram, we're going to fill it in exactly the same way. The first 2 electrons are going to go in the 1s shell. The next 2 are going to go in the 2s shell. Moving on to the 2p row, same way we did for the last element, we're going to fill in an electron for each room in the 2p shell, and then follow in with the second one. 3s is going to have 2 valence electrons, followed by 3p. We're going to fill in 1 electron for each room in the 3p shell, and then follow with the second one. Followed by the 4s, followed by the 3d. So each d orbital room gets 1 electron followed by a second one. So looking here, our valence electrons, we would have 2 for zinc. Our noble gas configuration, because zinc here is in column number 4, I'm going to move up to column number 3 all the way across, and I see that argon is a noble gas before zinc. So you write down argon in brackets and then continue counting electrons from there, 3s2, 3d10. Our next one here is boron. It is element number 5 on our periodic table. Right here at the top of our metalloid section, actually. So the electron configuration is going to be 1s2, 2s2, 2p1. So again, this is the p orbital, and it is the very first electron on the p row, which is why it only gets 1 electron in the p room. So here we've found our orbital diagram. The 1s is going to get 2 electrons, followed by 2s. And then our 2p orbital is only going to get 1 valence electron. So you can see here in our outermost shell, boron is going to have 3 valence electrons. and I scroll down here to the noble gas configuration. Same way as we've done the elements previous, I'm going to go up one row all the way to the noble gas and write that down in brackets, which is going to be helium. And then I'm going to continue counting electrons from there, 2s2, 2p1. All right, our last element is arsenic. It is element number 33 right here. It is in row number 4, which means we are going to have d orbital electrons in our electron configuration in our orbital diagram. So our electron configuration is shown right here, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then 4p3. So our outermost shell is the 4p row, and there's 3, so it has 3 valence electrons. Now our orbital diagram, it's going to be very similar to the one that we did for zinc. All of these shells previous are going to have 2 electrons, and I'm going to fill the p orbital in the exact same way. Every room is going to get 1 electron before I add a second. 2 electrons for the 3s orbital, 3p very similar. Every shell is going to get 1 electron before I add a second additional one. Then 4s here. 3d same way. Every room gets an electron, and then I go back in and I add a second one. Now important here, I have 3 electrons for the 4p shell. I'm going to spread those out, and so every shell will have 1 electron in the 4p shell. Sorry, every room will have 1 electron in the 4p shell. Scrolling down here to the noble gas configuration, same process as before. I find arsenic here in row 4. I'm going to go up to row 3 all the way across and see that argon is the last noble gas. So I write argon down in brackets, and then I copy down my electrons from there. 4s2, 3d10, 4p3. I went ahead and I wrote in our valence electrons here on our review and our noble gas, our family names here. Take a second to copy those down. And you guys are completely done with the review. I wish you good luck on your test.